All right. So part one, or calculation one, what is the weight percent of your solutions, A through B? So to get weight percent, we need the mass of the sugar that you added, which is approximately 2, approximately 4, approximately 6, approximately 8. In your calculations prior to that, you can see that you just get that by difference. You have to subtract the mass of the beaker or the flask to get the mass of sucrose. So you're going to divide that mass by the total mass. Now, I don't want to confuse you too much, but remember this is my sugar solution. Okay, this is A. I've got about 2 grams of sucrose, and I added about 30 or 40 mils of water, and it's all dissolved. I got a mass of this, right? And I get the whole mass of the solution simply by taking that final mass and from that subtracting the tare mass of the beaker. Okay, so that goes in the bottom. To get parts per 100, you multiply by 100%, and you have weight percent for A. Okay, and you're going to do that for A through D. Do this for all solutions. So for the second calculation, it's that simple kind of quick and dirty. Remember, you're going to do 1 aliquot before you turn your attention to your 4 solutions. You're just going to do water. That's what that is. Mass of the water divided by the volume, which is 10.00 milliliters. And then you need to come up with the density of your 4 solutions, which you should have that data by now. Okay, it's the mass of that aliquot that you weighed. You got that by difference. And then divide that by the volume. And that transfer volume is always 10.00 milliliters. Okay, so those actually then are these, you have enough to go ahead and do your plot. For each solution, you have a weight percent and you have a density. Weight percent, density, weight percent, density. What's the weight percent sucrose for the water? For the water, just the pure water that you get out of here. How much sucrose should be in here? 0. Yep. Yeah, so you have ordered pairs for actually 5 ordered pairs now. Using Logger Pro. So there is my little graph. I think we'll finish this thought and then I'll pull up Logger Pro just briefly. So that actually, and I will push this document out under Twitter as a PDF, but that graph is what I showed you before. You guys told me increasing density with increasing weight percent sucrose. I agree.
When you're saying aliquot, what are you referring to?
Aliquot is just a subsample of something that's liquid. So aliquot is what you're pipetting up. So now the coup de grace, and actually if you're looking for what to include in your summary somewhere, okay, in your summary somewhere, you should tell me what the weight percent of these are based upon the densities. Okay, so that's kind of, in fact, that's probably the biggest thing I'm looking for. What's the weight percent of sucrose in these? Remember, one's diet and one's not. Okay. So I'm going to pull up Logger Pro. Now, if you hear me lapse, it's called, instead of Logger Pro, if you hear me call it graphical analysis, that's what it used to be called. So it's been Logger Pro for a few years now. It's a nice program. Pretty much all of what we do in Logger Pro, you can also do in an Excel spreadsheet with graphing, but I really prefer Logger Pro because it'll have some advantages, I think, with kind of bringing in our vernier data from our LabQuest units. So any questions about that? I think, let me read the calculations, but usually my calculations say, whenever you have a graph like this, you need to give me a hard copy of the graph, and don't wait till the last minute to do this or ask me if you have questions, but you need to somehow get a printout of that puppy. And whenever there's a graph, you also need to give me the XY coordinates. Okay?
So like the Excel document that we do, basically.
Yes, but don't use Excel, use Logger Pro. Yep.
Excuse me, I apologize for coming in late. Did I miss something about, do we have access to Logger Pro on the computers in this building, or?
Yes, and you also, and I don't think I mentioned that before, I sent you an email so how you can get Logger Pro free because you're enrolled in this class.
Okay.
And we have vernier products. So as a student in this class, you get the program free. It's a nice little program. And it's also installed on several of the computers in the computer lab. So, yes and yes. Okay. And if you have a snag, sometimes you can just bring it on bring a file that you're working on. If you're working on a graph, it's a file. Just bring the file into me, and I have it in my office. We can kind of play around with it. So
On the thumb drive.
on thumb drive. It's just a little file. Any other questions? I think that about does it. So let's look at graphical analysis. Oops, see, I did it. Let's look at Logger Pro real quick. So this is Logger Pro from last year. I think they've come out with updates this summer. So, bless you. Yours might look a little bit different. You already see the X and Y, and you can't break anything, okay? So let's just go ahead and plug in a few. Let's see, X is going to be, what we say, our weight percent, and Y is going to be our density. Actually, as you might imagine, I can double click on that X up there because I want to label that thing. Okay, so I can go ahead and do weight percent. Units will be, I'll go ahead, it's kind of unitless, but I'll put percent. And I'll make this density. And it's going to be grams per mil. And let's just go ahead, our water, weight percent, sucrose is going to be 0. Density, we hope it's about 1.00. Okay. I'm just kind of guessing these. Let's just go with 2 grams being 2%. I know it's not. 4 grams being 4%. 6 and 8. Of course, they won't be that percent, but I'm just making it. And you guys told me it's increasing density. Now watch what happens when I start filling in these numbers. Look at the graph over here. It's so smart. So I'm going to go with the density. It's kind of outrageous, 1.23. Okay. I'm going to go with the density here of 1.8. That's really crazy. And 2.1. And 2.7. Okay, yeah, so you kind of see hopefully the dots along the bottom. Not bad, not bad. I'm not real thrilled with the auto scaling because, they always tell you when you want to do your dots so it uses up, I don't know, 2/3 of your graph, something like that. So I can fix that. Now, let's go ahead. I guess one of the things, let me show you how I fix that. I'm going to do a right click on my graph. When I did a right click on my graph, I can click on graph or auto scale. Graph options. Auto scale. That's what it said. One of the things you're going to want to do is there's no line here. You're going to want a line. That's under, I believe it's under Analyze. And you are going to do a linear fit. Voila! Okay, so your graph should look something like this. Now there's a little bit of a scatter. Some of you guys know that there's a test for fit or linearity by the correlation coefficient. That's the one I usually use. The closer that is to 1 if it's a positive slope, and -1 if it's negative slope, then the closer it is to 1, then the better your fit. So I have a little bit of scatter there. Okay, I guess I have some notes like in the appendix, I think, back there about how you add. Do you guys want to see how you add a title and everything? Because you need a title. It's under graph options. If I do a right click, all sorts of things there. I need a title to this thing. A good title, if you're not feeling creative, is whatever you have plotted on your y-axis versus whatever you have plotted on your x-axis. And I'm not feeling very creative. So this would be density versus weight percent. Density, VS for versus, weight percent. Okay, done. Okay, I'm close. I'm really close. When I go to grade your graphs, what I'm looking for is a title. I just put it there. I'm looking for your axes that are labeled, what it is in units, And in Logger Pro, it automatically took that from my column headings, so that's kind of nice. The one last thing I probably want to show you is how do you, given a weight percent, excuse me, density, given a density of your unknown, how do you go ahead and pick off the weight percent? So there's the term extrapolate, which means that we have a density that lies in our calibration points. So I am going to, and did I say extrapolate? I'm going to interpolate. So data, interpolate. Okay, now this little box up here showed up. And notice that wherever my mouse is, I got this little box up here. So I'm going to go ahead and what if my density was 1.95? So 1.95, you're like, oh, it must be between 4 and 6%. So what you do is you play a little game, 1.95, you follow the curve, 1.95. Okay, somewhere in there. It's kind of a, well, yeah, I'll buy that. 1.95 is the density. And now we know the weight percent, however many significant figures we're allowed, you know, we'll go 4.9%. Okay? Any questions?
What was the name of that word again?
Interpolate.
Interpolate. That's under data.
Yep.
And for the final, will we be graphing the unknowns as well?
Yes, now the unknowns won't be added to your as calibration points. The unknowns, actually, you're going to see what the density is and then see where it intersects with your calibration curve.
Okay, so we're not going to add the point onto the graph itself. We're just
Right.
going to interpolate it with this tool.
And I've seen students do it two ways. There is a way, I think, I've played around to print this. You can actually print this somehow during interpolation mode. If you can't, then just go ahead and print your regular graph and just pencil in or pen in where your unknowns are with regard to density, where they intersect your calibration curve, and then what that corresponding weight percent must be.
Can we just do it, have the screen up and screenshot it?
I would think you could just
Just
have
print that and use that?
Yeah, I think so. Are there any other questions? I need to see that for both unknowns. Yeah, and if you have questions about graphical analysis, let me know.
Both unknowns can
Or-
do the same thing, right?
Both unknowns, yes. That was
Can go on
the,
same.
right. Any questions? Sweet. Okay. Meet you on the other side.